Hello guys, here's a problem from today's Codeforces contest. So you're given two binary strings, call them A and B, of length n. You want to try and get A to be equal to B by applying a series of operations on A. The operations you can apply is, number 1, replace A with A XOR A left shift k for some integer k between 1 and n, or number 2, replace A with A XOR a right shift k for some integer k between 1 and n. Basically, right or left shifting shifts all the bits in that binary string by that amount to the left or right, and when it goes outside the n bits, they disappear, and the new empty spots are replaced with zeros. The problem says you want to try and find a sequence of operations that makes A equal to B, using no more than n operations. Now, how do you solve this problem? First of all, read the constraint again. Realize that it says that you can only use at most n operations, and since n is the number of bits in the binary strings, this tells you that perhaps each operation must fix one of the bits in A to be equal to the corresponding bit in B. So n operations and n bits, so one operation must fix one bit. Now for the solution. Assume that the leftmost bit in A is 1. Realize how, with the help of bit shifting and XOR, we can choose what the rest of the binary string will be with n-1 operations. Here's a demonstration of the idea. Basically, we can build up this array from left to right, and since we bit shift to the right more each time, the ones we already fixed doesn't change, meaning we can focus on just changing the next one. We can expand this idea. Consider the reverse. The rightmost bit in A is 1. We can do the same thing as before, but in reverse, from right to left. Also realize that it doesn't just have to be the first or the last bit that is 1. Consider the leftmost case. We can choose the leftmost bit from the bits that are 1 and repeat this algorithm, because if we choose the leftmost bit from the bits that are 1, all the bits to the left of it will be 0, so they will not affect the numbers when XORed, because 1 XOR 0 is still 1 and 0 XOR 0 is still 0. Now, with these two algorithms that we have created, are you convinced that from the rightmost bit that is 1, we can fix everything to the left of it, and from the leftmost bit that is 1, we can fix everything to the right of it? Now, these observations are enough to finish the problem. Firstly, we find the leftmost bit in B that is 1. After we do this, we check if that bit position in A is also 1. If it isn't, we can just shift the bits and XOR to make it a 1. After we do this, realize that we want every bit to the left of this bit to be 0 to match B. So, choose the rightmost bit of A that is 1. Realize that we can make all the bits to the left of the first bit we fixed to be 0 using our algorithm from earlier. Afterwards, realize that the bit we fixed at the beginning is the leftmost bit that is 1 in A. We now repeat the algorithm from earlier that goes from left to right, and we fix all the bits to the right of it. Now, since we used one operation for each bit fixing, we are guaranteed that this sequence of operations does not exceed n. And once we calculate these and once we store them in an array and we output it, we're done. I hope you enjoyed the solution and stay tuned for more interesting and cool problems.